What we're going to do is take up the answers to forming compounds. So grab your worksheet out or your notes and let's see how you did. All right, so the first question was done for you. It gave you calcium and fluorine are the elements that are going to be reacting together. So we're going to have our calcium that forms an ion or a cation, a positive ion. And remember with calcium, it originally had 2 electrons in its outer energy level, and those 2 got pulled away from the atom. So now we have a positive 2 charge. Now, if we're reacting it with fluorine, fluorine had 7 electrons in its outer energy level. It's in group 17. It's going to form a negative ion called an anion. And one of these electrons in here is one that it picked up from somewhere. But if we look at just calcium, just fluorine on its own, if we had positive 2 here and negative 1 here, well, it doesn't balance out, does it? So we need to get this to be neutrally charged. So we're going to add another fluorine in here. And so now if you look at this entire compound, overall, we have positive 2 and we have negative 1 and negative 1, which make negative 2. This overall thing is neutral. So our chemical formula is calcium. We have 1 calcium, so there'd be a little 1 down there. And then fluorine, right? A little, oh, don't ask me why that's got F either. That's a mistake there. It should just be F. And then we've got calcium fluoride. Okay, that's the name. And we change that ending to IDE. All right, and metal always goes first for both of these. So let's take a look now at magnesium and chlorine. So first thing we put in there is our cation, our ion diagram for magnesium. It has lost the 2 electrons that would be on the outer energy level. Remember, it's in group 2, so it's going to have 2 electrons. Those 2 electrons have been pulled off by something that has a greater pull of electrons. So we've got our chlorine. Now our chlorine originally had 7 electrons as outer energy level. It's in group 17. And if it just so happened to be floating by when those electrons were released from the magnesium, it's going to scoop it in here. So this is going to give it an overall charge of negative 1. This is the anion. It's negatively charged. Now this whole thing to form a compound is not going to be neutral. We're going to have a positive 2 here and a negative 1 here, and that's not again being neutral. So what we're going to do is we're going to stick in another chlorine to try to neutralize this whole thing. There we go. So we've got positive 2 and 2 negative 1s, and that ends up being neutral. So the chemical formula here, in our chemical formula, there's 1 magnesium here, and there's 2 chlorines here. So our chemical formula is going to be MgCl2. Remembering that there's a little 1 that's in there that we don't need to write. And its chemical name is, remember metal always goes first, it's going to be magnesium chloride. Change the ending to IDE. Alrighty, next one. We've got potassium and oxygen. So our ionic structure for potassium is going to look like this. Potassium was in group 1, it had 1 electron in its outer energy level, and that's being pulled off for some reason by something that has a greater pull of electrons. So now we're going to have our oxygen. Now oxygen was in group 16, which meant it had 6 electrons in its outer energy level. Now these 2 guys here were unpaired. So if it pulls electrons from somewhere, we're going to have a new electron there and a new electron there, which is going to give this an overall charge of negative 2. So if this was forming our compound at this point, it couldn't, because this has a negative 2 charge, this has a positive 1 charge, so it's not balanced out to be neutral. So we're going to need to have 2 potassiums here. And our chemical formula, in this case, we're going to have 2 of our metals. Metal goes first, so we're going to have 2 potassiums, so K2. And remember, the 2 at the bottom tells you the number of atoms of that element, and then 1 oxygen, understood to be a 1 there, and its name is potassium oxide. Change that ending to IDE. All right, our next one, aluminum and phosphorus. So our ionic structure for aluminum is in group 13, so it originally had 1, 2, 3 electrons in its outer energy level. Those are pulled off, they're gone now, so we don't draw in the outer electrons for our metals. So here's our cation here, we don't need to worry about those electrons because that outer energy level is now empty. However, with phosphorus, phosphorus was in group 15, so it had 15 electrons around its outer energy level, right? 3 of those electrons were not paired up, so this is a new electron all through here. Okay, 1 new electron there, 1 there, 1 there, to make sure that we have 8 in the outer energy level. So this becomes nice and stable, similar to the closest noble gas. All right, and if we just look at this thing, it's already neutral. So our chemical formula is ALP. So there's only 1 aluminum and 1 phosphorus, and its chemical name is aluminum phosphide. Right? Our second last one, so we've got aluminum now and fluorine. So again, here's our ionic structure. Aluminum lost 3 electrons. We've got our fluorine here. Right, so we've got F, remember this is in group 17, it needs 1 electron, so now it's got 8 electrons, it's got an overall charge of -1, so we've got 1 there. If we were to make the compound out of this, it wouldn't happen because we've got +3 here and -1 here. There's no way that's going to end up being neutral. So we stick a second one in there. Well, still not neutral, is it? Still +3 here and -2 here. So we're still not where we need to be at neutral. So we got 1 more coming in here. So if we were to make aluminum fluoride, we would need to use 1 aluminum and 3 fluorines to make that compound. So our chemical formula is going to be AlF3. And fluorine has the right chemical symbol here compared to that first example. And our chemical name is aluminum fluoride. Alrighty? So our last one, this one was a toughie. Really not that hard once you start drawing it out, but this one was a little bit more complicated. So we've got magnesium and phosphorus. So magnesium was in group 2 and lost 2 electrons, so it has an overall charge of +2. That's our cation. So we're going to draw our phosphorus in here, all right? Phosphorus, again, remember it had 5 electrons at its outer energy level, so it's going to need to gain 3 in order to have 8 around the outside, and its charge is going to be -3 because it got 3 electrons. Well, this does not balance out at all, does it? It does not bring us to neutral. Okay, so let's put in another magnesium. Alrighty? Oh, okay, so now we've got another magnesium, but on this side here, we now have a charge between the two of these of +4, and our anions, our phosphorus has a charge of -3. So this is still not going to be neutral. This is going to be +4, it's going to be -3. Okay, fine. So let's put in another phosphorus here. Alrighty. So this is now -6. Well, look at this. This is -6 for our ions, and it's +4 for our cations. Still not neutral. So let's add another magnesium in there and see what happens overall. So now we have 3 positively charged magnesium, so they're each +2, so our overall charge here is +6, and we've got 2 phosphoruses whose overall charge is -6. Bond these guys together, we have an overall charge of neutral, or not a charge of neutral, we just have overall as neutral. So our chemical formula is going to be Mg3 because we have 1, 2, 3 magnesiums, so Mg3, and we have 2 phosphoruses. So our chemical name, again, remember metal always goes first, is magnesium phosphide. Okay, so make sure, double check your sheet, anything you got wrong, fix it up, replay this video if you're still not too sure, and there's a little quiz for you to do, and that's it for this lesson.